Hello students, in the last video we have discussed examples on Fourier series, means how to expand the Fourier series in a given interval of the given function. So now let us discuss some more examples on the same expansion. So here the first example is obtain the Fourier series for the function f of x equal to e power x in the interval 0 to 2 pi. So now depending on the interval, first we need to write the general formula for the function. So therefore here f of x equal to a naught by 2 plus summation over n equal to 1 to infinity a n cos nx plus summation over n equal to 1 to infinity b n sin nx. So here the interval is 0 to 2 pi. Now regarding that interval we need to find the Fourier coefficients a naught, a n and b n. So here a naught is equal to 1 by pi integration over 0 to 2 pi f of x dx. Then it is equal to 1 by pi integration of this one is e power x and the limits are from 0 to 2 pi. Hence it is 1 by pi e power 2 pi minus e power 0. So e power 0 is equal to 1. So therefore 1 by pi into e power 2 pi minus 1, that is a naught. This is a naught. Then a n. So a n is equal to 1 by pi 0 to 2 pi f of x into cos nx dx. So here e power x into cos nx. So by the for the integration of this one, we cannot apply the Bernoulli's form of the integration, because for that Bernoulli equation or the Bernoulli rule of integration, one function should terminate after some finite number of differentiation, but here both the functions are not terminating because the differentiation of e power x is e power x only, but independent of the order of the differentiation, and cos nx is also same. So therefore here we are applying one standard formula. So that is here e power integration of e power ax into cos bx dx, e power x cos bx dx, that is equal to e power ax divided by a square plus b square into, so here first e power ax as it is divided by a square plus b square into a cos bx plus b sin bx. So this is the formula of the integration. So e power x as it is divided by a square plus b square, then a cos bx plus b sin bx. Now compare this integral with this one. So after comparing we got a is equal to 1 and b is equal to n. So therefore 1 by pi into e power x divided by a square is 1 and b square is n square into here a cos bx, that is cos nx, plus b sin bx, and b is equal to n sin nx from 0 to 2 pi, right. So now this is equal to 1 by pi. Now put the upper and lower limits in the equation. Now this is equal to e power x, that become e power 2 pi divided by 1 plus n square, and we know that cos 2n pi is equal to 1 and sin 2n pi equal to 0. So therefore this is equal to 1, and this is the value of the function at the upper limit minus 0. Now x equal to 0 means this is e power 0, which is equal to 1, then 1 divided by 1 plus n square into, here cos 0 is 1, sin 0 is 0. So therefore it is equal to 1. Then this is equal to 1 divided by pi. Here we can write this as 1 divided by 1 plus n square as a common, remaining e power 2 pi minus 1. So therefore it is equal to e power 2 pi minus 1 divided by pi into 1 plus n square, that is a n value. And Bn, so here the formula for Bn equal to 1 by pi 0 to 2 pi f of x into sin nx dx. So here f of x into sin nx dx, this is also cannot be integrated by the Bernoulli rule of integration. So therefore here e power ax into sin bx, which is equal to e power ax upon a square plus b square into a sin bx minus b cos bx. So this is the formula for integration of this function. Then here Bn equal to 1 by pi. So here also a equal to 1 and b equal to n. Then it is e power x by 1 plus n square into a sin bx is there, that is sin nx minus b cos bx, and b is equal to n cos nx from 0 to 2 pi. Then Bn equal to 1 by pi. Here first apply the upper limit of the function. So upper limit is 2 pi. Now this becomes e power 2 pi divided by 1 plus n square into. Now here sin 2 pi is 0 and cos 2n pi is 1, and then this becomes minus n. This is the value of the upper limit, minus. Now x equal to 0. X equal to 0 means this is 1 divided by 1 plus n square, and sin 0 is 0, cos 0 is 1. So again this is minus n. So therefore it is 1 divided by pi. Here the common terms are n divided by 1 plus n square, right? So remaining minus e power 2 pi, because minus is there, and minus into minus becomes plus 1. So therefore here n divided by pi into 1 plus n square, and this is 1 minus e power 2 pi, which is the Bn value. So therefore from equation 1, so here equation 1 means the first formula. So here this is the first equation. So in this equation we need to write down a naught, a n and b n. So a naught equal to 1 by pi e power 2 pi minus 1, b n equal to e power 2 pi minus 1 divided by pi into 1 plus n square, and here b n equal to this one. So therefore that equation becomes f of x, that is e power x equal to a naught by 2, that is 1 divided by pi e power 2 pi minus 1 divided by 2 is there. So therefore that is 1 by 2 pi plus summation over n equal to 1 to infinity a n. So a n is e power 2 pi minus 1 divided by 1 plus n square cos nx plus summation over n equal to 1 to infinity bn is n divided by pi into 1 plus n square 1 minus e power 2 pi into sin nx, which is the required expansion of the given function in the interval 0 to 2 pi. The second example is obtain the Fourier series for the function f of x equal to x square in the interval minus pi to pi, and hence deduce that pi square by 12 equal to 1 minus 1 by 4 plus 1 by 9 minus 1 by 16 and so on up to infinity. And the second one is pi square by 6 is equal to 1 plus 1 by 4 plus 1 by 9 plus 1 by 16 and so on up to infinity. So here we can observe that the given function x square is an even function. So already we have discussed about the expansions of odd and even functions. If the function is even, then the third coefficient is equal to 0, and if the function is odd, then the first two coefficients are equal to 0. So therefore first observe the function, because no need to find the 0 values, right? So therefore you can save the time while finding the Fourier constants. So here f of x equal to x square is an even function, therefore Bn equal to 0, means no need to find the value of Bn by calculation, and remaining is function f of x can be written as a0 by 2 plus summation or n equal to 1 to infinity an cos nx, means here just we need to find a0 and an. So now a0 is equal to 1 by pi integration over minus pi to plus pi f of x dx. So 1 by pi, here integration is x cube by 3 minus pi to plus pi, then it is equal to 1 by pi. Here put the upper limit, that is pi cube divided by 3 minus x equal to minus pi, that is minus pi cube, so this becomes plus pi cube divided by 3, which is equal to 2 pi cube divided by 3 pi. So pi and pi will get cancelled, which is equal to 2 pi square divided by 3, that is the value of a0, 2 pi square by 3. Then an, so an is equal to 1 by pi minus pi to plus pi f of x cos nx dx. So now an equal to 1 by pi. Here we can use the Bernoulli rule of integration, because that x square become 0 after 3 differentiation. So therefore here first function x square as it is, integration of cos nx is sin nx divided by n minus differentiation of x square, that is 2x, then integration of sin nx is minus cos nx divided by n square plus differentiation of 2x is 2, and integration of cos is again sin, so minus as it is sin nx divided by n cube. Next term will be equal to 0, because differentiation of 2 is 0. So from minus pi to plus pi. So therefore it is 1 by pi x square sin nx divided by n. Now minus into minus becomes plus 2x into cos nx divided by n square, then minus 2 into sin nx divided by n cube, from minus pi to plus pi. Now the upper limit. So here we know that the value of sin n pi is 0 and cos n pi is minus 1 whole power n. So therefore here The first function is sin nx, and for x equal to pi this is 0, and this term is also 0, and remaining only this one, that is 2 pi minus 1 whole power n divided by n square, because cos n pi is minus 1 whole power n divided by n square is that constant. So this is the value for the upper limit minus. Now lower limit is minus pi. So here now x equal to minus pi, this becomes minus 2 pi, so already minus is there, so therefore plus 2 pi minus 1 whole power n divided by n square. So therefore it is 2 pi plus 2 pi, that is 4 pi, 4 pi minus 1 whole power n divided by n square pi. So pi and pi get cancelled, it is 4 into minus 1 whole power n divided by n square, that is the value of an. So now here this is the first equation, right? So we know that a naught is equal to 2 pi square by 3 and n equal to 4 whole power 4 into minus 1 whole power n divided by n square. So therefore f of x means x square is equal to a naught by 2, that is 2 pi square divided by 3, 1 by 2 is there, so therefore by 2 plus summation over n equal to 1 to infinity bn is 4 into minus 1 whole power n divided by n square cos nx. So here 2 and 2 get cancelled, it is pi square divided by 3 plus 4 is constant taking outside, then remaining n equal to 1 to infinity minus 1 whole power n divided by n square cos nx, which is the required expansion of the function. Now to prove the required result, so let us write this as x square pi square by 3 plus 4. Here let us write this in the series form. Now for n equal to 1, for n equal to 1 this is minus 1, so minus 1 divided by 1, and this is cos x for n equal to 1, and for n equal to 2 this becomes plus 1 divided by 2 square cos 2x minus for n equal to 3 1 by 9, otherwise here 2 square can be written as 1 by 4, so 1 by 4 cos 2x minus 1 by 9 cos 3x plus 1 by 16 cos 4x, and so on up to infinity. So this is the expansion of the that series. Now to prove the results, here the results are, the first one is pi square by 12 equal to that 1 minus 1 by 4 plus 1 by 9 minus 1 by 16, and second one is pi square by 6 equal to 1 plus 1 by 4 plus 1 by 9 plus 1 by 16, and so on up to infinity. So to prove those two results we need to substitute the value of x. Now for the first one put x equal to 0. So x equal to 0 means here it is 0 equal to pi square by 3 plus 4 into. Now put the value for cosine. So cos 0, cos 2 into 0, cos 3 into 0, cos 4 into 0, they are all become 1, right? So it is minus 1 plus 1 by 4 minus 1 by 9 plus 1 by 16 and so on by substituting x equal to 0. Then it is equal to pi square by 3 is equal to, now shifting all these terms to LHS, this plus 4 becomes minus 4 minus 1 plus 1 by 4 minus 1 by 9 plus 1 by 16 and so on infinity. Now here cross multiplying, just multiply 4 by 3, then that is pi square divided by 12, and now multiply this negative sign to all these terms, that becomes 1 and plus becomes minus 1 by 4 plus 1 by 9 minus 1 by 16 and so on up to infinity, which is the required result, that is pi square by 12. Then second is, for the second result put x equal to pi. So therefore here x square is there, so therefore that becomes pi square, it is equal to pi square by 3 plus 4 into, so here we know that the value of cos pi and cos 2 pi, cos 3 pi and so on up to infinity, right? So here this is the function x square equal to pi square by 3 plus 4 into this one. So whenever the coefficient of x is odd, its value is minus 1, and if it is even, it is equal to plus 1, that is for the cosine function. So therefore here cos x is there, now this becomes cos pi and its value is minus 1, so already minus is there, so therefore that is plus. Then for cos 2 pi, that is plus 1 only, so therefore 1 by 4, and cos 3 pi minus 1, so minus is there, so plus 1 by 9 plus 1 by 16 and so on up to infinity. Now this is pi square minus pi square by 3 is equal to 4 into 1 plus 1 by 4 plus 1 by 9 plus 1 by 16 and so on up to infinity. So pi square minus pi square by 3, that is 2 pi square by 3 is equal to 4 into 1 plus 1 by 4 plus 1 by 9 plus 1 by 16 and so on. Then here 2 ones are 2 twos are, then it is pi square divided by 6 is equal to 1 plus 1 by 4 plus 1 by 9 plus 1 by 16 and so on up to infinity, which is the required result. So therefore for x equal to 0 we got the first result, and for x equal to pi we got the second result.